A lot of today's AI narrative is based on this idea that, we've already reached the peak of human ability, and the only way to expand is to delegate to the AI because we can no longer understand systems. And this is a very luring narrative, but it's flawed.
Welcome to another amazing episode of Wicked Problems. I think it's amazing anyway, and I'm today joined by Tudor Girba. In the work that I do, I'm always looking at ways to bring the time it takes to do something, the lead time from inception to delivery, down. And a lot of people look at this and they look at it in different parts and different aspects of the organization. This could be anything from, how do we reduce the ideation time from strategy through to how do we get faster feedback loops and so on. Tudor is one of the brains behind something called Moldable Development. And what that's doing is enabling us to bring down the lead time dramatically for people who are working on legacy systems or maybe moving legacy systems, migrating them across to newer technology. Because part of the problem is how do you visualize what the actual system is doing, the legacy system? And that's a problem that Moldable Development solves. And when you can solve that problem, that visualization that you don't have if you're just reading code, when you can solve that visualization, when you can see what's going on, well, then you can bring down the amount of time it takes to either maintain that code, change that code, or migrate that code into another platform because you have the full picture of what's actually going on and what's important. There's way more to it than that. So I'm going to hand over now to Tudor, who is going to help me unpack what Moldable Development and Glamorous Toolkit really are. Please enjoy the show and follow the links underneath here if you want to learn more. Tudor, welcome to Wicked Problems. It's great to have you.
Well, nice to meet you, Toby. Thank you for having me.
Tell me all about Moldable Development.
All about it?
All about it. Everything.
I see.
No,
everything.
We've only got like half an hour, but everything. Well, just give us a flavor, an overview of Moldable Development for those that maybe haven't come across it.
Okay, well, let's start with the problem it solves. So the problem, since a long time in software development, the largest problem in software development is how do you make sense of the existing systems? And we can see this problem manifests itself when organizations have large systems that they cannot change. They cannot evolve to meet new requirements, new needs, new opportunities. This has been the largest cost in software development that we can measure by just looking at what developers do. And what they do is they read code, trying to make sense of it. But the issue with reading is that it doesn't really scale. It doesn't work so well when your system is larger than you can actually read. So the consequence of that is that because nobody has time to read the whole system, then most information is inferred. And so most decisions that are being based on that information are essentially made based on beliefs. In software engineering, that should not be, or in an engineering discipline, that shouldn't be the way we make decisions. So the alternative is to fix the way we get ourselves informed, because the reading part is just a technique, it's just a tactic that is being used to extract information from the system. And we do need the information from the system because that's where the truth is. We should just not employ reading for most of this gathering because it doesn't scale and also because it's not particularly accurate. Now, why do people read? That's another interesting question to explore. And I actually asked thousands of developers, first of all, do you agree that you spend more than 50% of your time reading code? And basically they say yes. And there are good studies about this, and like oldest references to this that I know of is from somewhere around 1979. So this is not a new problem. It's an old problem. But it's an old problem that hasn't necessarily been addressed. And then the question is, why not? And then, because 50% or more, it just simply accounts for the single largest cost we have. And not optimizing that one sounds, yes, at least interesting. So I'm asking developers another question, which is, when was the last time you talked about how you read code? It's a reasonably simple question, but developers, they have a hard time answering it because they never think about it. It's not a subject of conversation. And because it's not a subject of conversation, it's not explicit. And it's because it's not explicit, it has never been optimized. And we're literally talking about the single largest cost we have, and moldable development is a method to optimize software engineering for this single largest cost we have. I mean, the AI world, where code is now being generated at even larger speeds, greater speeds than it was before, it becomes quite obvious that developers only read code, or mostly read code now. So it is becoming even larger as a problem, but the problem is not new. And so we don't have to, the solution isn't necessarily AI related, although AI can help, or the LLMs, they can help. But we need a better, first, before we're going to talk about how we're going to use LLMs for that, we first have to go and understand our discipline more rigorously, and then we're going to see how do we automate it further.
Because we can't train the LLM if we don't know what we're training it to do.
Well, yes, and because the LLMs are not decision-making machines, or they'll make choices, but it's just not necessarily, they're not necessarily grounded in good or bad, or valuable or not valuable. They'll make choices. And what we should be doing, so as long as humans want to be responsible for what goes into a production system, the choice has to be the one of the human. And so the question is, how do we go about understanding an existing system or propositions that come from AI? But the problem is basically the same. And the way of, the idea of relying on reading is not a solution.
So we have to understand the code. We can't rely on the AI to understand the code. We need to understand the code ourselves, but we're spending far too much time trying to do that by reading it. So moldable development helps us get past that problem. I think you talked about it somewhere online or at a conference as being, related to test-driven development in some ways as well.
It is, yes. So first, we cannot rely on AI to do the understanding. So if we want to make the decision, then we have to understand. There's no going around this. How do we inform ourselves so that we can make the choice? That's the question. So obviously, today people would say, oh, let me use an AI and ask it to summarize the system, or say, ask the AI, draw me a diagram about the system. We've done this one. So I'm writing a book with Simon Wordley about moldable development. It's a book called Rewilding Software Engineering. We're writing it in the open. And in chapter 6, we were talking about myths of software engineering. And one of the experiments that we are showing there is we took an LLM, so a leading LLM, and then we asked it, go and find the dependencies of a system. And it found an impressive amount of components, like 100 plus components and like 200 or so dependencies and so on. And it's very impressive. And it's exciting. But when we looked at the actual dependencies, like all the list, if you list the entire space deterministically, we saw, it actually missed like 30% of the whole space. So now the question is, why would you want to base your decisions on something that is not representative, it's not necessarily accurate, and you can't explain? So that's not really a good input. And by the way, the same problem happens when we ask other humans to say what they think the system is, right? And this is what happens when we draw something on a whiteboard, like a picture on the whiteboard, or we look at the documentation that was written 2 years ago about some system, right? And first of all, we don't know how that diagram was informed, and the other one we don't know how accurate it is and how representative it is. So that diagram, a diagram manually created about the system, represents a belief of the author about the system, which is a useful piece of information. It's just not the same as representing the system. So the alternative, we want to build tools that deterministically produce whatever picture we want about the system. So when we sketch something on a whiteboard, let's say about the future system, we brainstorm how we want the future to be. That's an interesting artifact because it helps us externalize what we think, what we want. It's a communication tool. We impart our vision so that others can join and maybe help build it. But as soon as the system exists, the same picture represents a belief. This is not the same. So what we want is now, the picture is very useful, was very useful to build a mental model of what we want the future to be. But as soon as the system exists, what we would like, what we should want, is to make the system give us back the same picture. It's a very simple idea. So rather than us drawing the system, we make the system draw itself. And this now links back to your the question and the parallel to test-driven development. There used to be a time when we were, writing the documents as what we want the system to be, and then these documents would be translated into manual checklists that some people would go through, and then these checklists, this test, they were performed manually. They were compiled into some sort of a result, and there would be a committee that would decide whether or not the system is good enough to be released, and they would release it, and boom, only to find out that it crashes. That whole scenario, that whole organization was basically not necessary. It was just a crutch to circumvent the fact that we didn't know how to test. But then when we said, oh, what if we build the system and make the system also tell us if it fulfills the conditions that we said it should fulfill? That whole ceremony went poof away, and we could just handle much larger functionality, if you want, from systems. So the same idea, right? The test basically helps us answer the question, is this functionality conforming to my expectation? So is the input versus the output conforming to my expectation? That's the assertion, and that's what a test does. So a test is a little tool that answers that kind of question. They're very useful. These kinds of tools are very useful for functional questions. But there are all sorts of other questions that we have about the system that are not nicely decomposable as a functional problem. For example, architecture is such a thing. Performance is another one. Security is another one. And so on. We can go on and on. But those problems too lend themselves to the same idea. What if I have a question, what if I make it the job of the system to give me back the answer? That's it. That's what moldable development is.
I suppose when we do test-driven development, a lot of the time what we're doing is asking it to give me a functional pass. Right, so I want it to do X, it does X, but it doesn't tell me if it does X safely, if it does it in a way that's going to, burn up the CPU cycles, or that's going to, unexpectedly fill my data storage too fast, or cause me to spend a load on AWS or Azure or wherever I'm hosting, if it's in the cloud. It could still pass the functional test easily and not pass those non-functional aspects. And I guess also I was thinking, as you were talking, I was thinking about, in the past we had very good sort of auto documenting tools like Java Docs and so on, and they would give you quite good details about what this thing does functionally, but it doesn't tell you all those other aspects. So moldable development is kind of helping to address what does this system do from every angle, right?
Right. So maybe Java Doc was not it was an interesting way to elevate a little bit above the code, but not that much, in fact. So one way to think about it, a different way to think about it is, so it's possible to take a system, and the system has just tons of computation in it. But then if we put a user interface on top, non-technical people or people that have never seen that system can relate to and actually start manipulating it. That's the fascinating thing about user interfaces. It means that we can translate things from instant computation into ways that humans can actually understand and engage with. But what if we bring the same idea, but at all levels of abstractions? And there are lots of this. What if for any question, we would have some kind of a user interface that would expose that problem in a way that some other humans can actually engage and do something with it. So those tools, now if you think put another variable in it, it's impossible to reason about anything in a system or to perceive anything in a system except through a tool. So therefore, the tool through which we perceive is actually fundamental. It's not something that is optional. So now today, developers use some kind of, interfaces, maybe something they call maybe a development environment of sorts. But most of those development environments are actually very rigid. They all basically use the same kind of interfaces, regardless of the problem. But software, on the other hand, is very, very contextual. If you think about an app on your phone, right? if each app will come with its different interfaces. Even if maybe they're even sometimes similar, they'll still have different interfaces. And that's because the difference matters, context matters. And so, interesting enough, if you think about any enterprise system, it's doing exactly that. It takes some data problem, manipulates it, transforms it, and then presents it to some humans that will never see the raw data, but they will make much better decisions for it. And the way they do it is because that enterprise system is a bespoke solution for their particular problem and their particular context. This is what makes that one very valuable. A test, if you think about now, come back to a test is never downloaded from the web from somewhere. We always construct a test within the context of that system. Why? Because context matters. And so we have to build the test after we know the problem, not before. Simply because when context matters, we can't predict the specific problems people will have. We can only predict classes of problems people will have. The same idea can be then lended to or extended to user interfaces and to the experience of the development experience, the way in which you get to experience the inside of the system and manipulate the inside of the system, so that instead of having an off-the-shelf rigid experience, what if it can change depending on each problem? So just like how you build a test, every time you have a new problem, here in our case, every time we have a new question, we would build a little tool that would visualize the system or the part of the system that we're interested just for that particular problem. And then when we move on to the next one, and we will do this one maybe dozens of times per day. And this would then, some of these tools will become reusable, and they will compound over time. And this will mean thousands of such tools per system. So just like how we have thousands and tens of thousands of tests, we can have thousands, tens of thousands of little tools that construct the overall development experience. When we do this, these tools, they compress communication. They enable new kinds of value creation opportunities, not only on the technical side. The interesting kinds of opportunities actually arise from rethinking the way you create business value.
I mean, at the end of the day, when we create tools, when we create code, we're doing it in service of creating business value, right? So if a tool doesn't help us in that endeavor somehow, why are we using that tool? But if the tool can help us to get there more quickly, then we definitely want to be using the tool, right? Or maybe even not more quickly. More quickly, yes, but more robustly as well. And that ties me back to when you were talking about AI going through the system and looking at the dependencies. I think it was a roughly 10% it missed, something like that, right? And that's quite a big number.
10 to 30.
I mean, one of the problems with AI, for me at least, is that when it's wrong, it speaks very authoritatively. So it sounds very plausible in its wrongness. And so you might be convinced that it hasn't missed anything, right? And then the danger there is, well, you hit some scenario that you didn't know you could hit, and your code crashes, or something awful happens, or there's some reputational risk, or there's a security breach, or there's something of some importance and maybe magnitude catches the system or catches you as a business, and that's value destructive.
So two things here. So yes, that if there's no way for you to, again, if you get an answer from either an LLM or from another human about the system, but you have no way of verifying it against the actual system, you're in the belief land. It might be that the answer is correct. We just have no way of knowing. So then, which also means that you're in no particular position to make the choice about this. But then in the same experiment, we did the next variation of it. And the next variation of it was we took exactly the same prompt, but instead of asking it, give me the dependencies and the components and dependencies, we asked it, give me the code with which I can get the components and dependencies. Build me a little tool so that I can investigate independently and that I can use to produce the map or the components and dependencies deterministically. And that works very, very well because LLMs are incredibly good for that. Now, we use these kinds of tools. This worked before LLMs. So LLMs are not essential for creating these tools. Just like how LLMs are not essential for creating tests, although we use them now. Yeah, create me more tests. Great. And they're very good at doing that. So they're useful in that regard. But it's not a replacement for testing. And just like how we're not asking the LLM, for example, when it comes to functionality, we're not asking it, is the system conforming to my requirements? We're not using the LLM for that. No, instead we say, oh, LLM, please produce me the tools, the tests that I can then investigate and run myself, right? And those are like the tools. There's an intermediary step there, which is very important, that makes it engineering. So we can do the same with every other question that we have about the system, and this then will change the conversation we'll have about the systems. Now, you also mentioned here, the kinds of, like, how does this manifest? Let's say you have this 10, 30%, whatever difference gap between the picture and reality. What can it do? So yes, you're right. Like, it could be some sort of, let's say, catastrophic kind of situation, security breach or other things like this. But most of the time, what we are seeing is it's a much more silent penalty that organizations are paying. And they look like the system just never changes. So, for example, in the book that I'm writing with Simon, in chapter 2, we talk about one case study that I enjoy very much. I enjoy it very much when we looked at it. It was an organization that had the data pipeline. This data pipeline was like their main marketing data pipeline. So it was fueling like offers going to 40 million customers. So reasonably important. But the issue they had with this data pipeline was that from the moment they had the data until the moment they were sending the offers, it took one day. Right. So and they were in a business to consumer business, and so one day was very, very long, especially in that space. So, and the board knew about the problem. The CIO demanded this must be much faster. And so they started working on it. And 3 years later, somebody measured. It took exactly one day from the moment they had the data until the moment they were sending offers. So then somebody then asks, what did we do for 3 years?
Yes.
And so, so when we looked, they asked us to look at the system. That's what we do at Feenk. When we looked at it, and in a couple of weeks, we basically started asking, we always ask them, tell me what you believe the system is. And they drew for us 4 boxes that were making this pipeline. And then we asked, so what do you think? What's your hypothesis as to what do you want to look at? So, well, we're probably producing too much data. Okay, so we started in order to answer that question, we've never seen that system before. So in order to give them answers about their own systems, what we did was, what we typically do is we take these pictures, and then we want to build a tool that looks at the system and then produces the same picture back. 2 weeks into this process, we went back and said, look, the output of the first box doesn't seem to match the input on the second box. Are you sure you don't have something else here in between? And they found the whole system.
Wow.
They were not aware they have it.
Wow.
And that's the problem. So the issue is, right, when your mental model is so different from reality, you're basically dancing around the fire to make rain happen. And then there will be all sorts of debates. Should we dance clockwise or counterclockwise? And there will be evidence gathered as to why clockwise is better than counterclockwise dancing to make the rain happen. But of course, reality will have its own way of working. And in our case, the system is reality, and the system will change when the system changes. And it doesn't change when it doesn't change. And that's it. It doesn't matter how much you wish it or will it, it won't happen. And so that's the silent penalty that organizations are paying. And it's everywhere today. And you'll see it in all this, for example, all the poor success of any modernization efforts, right? So we looked at some of the latest reports, and one of them said it's about 26% of modernization efforts succeed. 26%. That's ridiculously low. But on the other hand, we have the chance of working with organizations, or at least one organization, which is in the complete other side. They have invested significantly into software engineering, and they have done it for like decades, and they are able to migrate. So they have a history of migrating more than 20 such systems over like 2 decades, and they have done it in less than 1 year for each of them, and successfully every single time. On the probability alone, right, if you say 26%, trying to do it 20 times plus in a row, you will get like it's 1 in 500 billion, the chance. That's the cool thing here is that so the problem is enormous today, so that's not a cool thing. But the cool thing is that the solution seems to actually work. And the way the solution works is we have to invest in the tools with which we perceive our systems, because that's where the bottleneck is. The bottleneck is not in our ability to understand. The bottleneck is in our ability to perceive. A lot of today's AI narrative is based on this idea that, we've already reached the peak of human ability, and the only way to expand is to delegate to the AI because we can no longer understand systems. And this is a very luring narrative, but it's flawed because, in my view, we are very far from even knowing what the peak of human ability is, because we have never experienced at scale what happens when humans actually get to see their systems. In our experience, as soon as we can enable them to see their own systems, their decision-making increases significantly.
You talked about delegating to the AI. There's a danger that people abdicate to the AI, so they give up their decision-making capability by really placing their trust so far into the AI. And then eventually, I suppose, in many cases, they'll come unstuck. But it might be that they have a much bigger problem to solve. If I wanted to adopt moldable development, how do I do that?
First, we encourage people. Pretty much everything we do is free and open source. We encourage people to read the book that Simon Worley and I are writing. It's free, available. We're writing it in the open with the idea of translating the more technical details into something that is more consumable, all the way to, let's say, a strategy level, so a C-suite. But if people want to look and practice, actually go and solve problems, we are also we're building a technology which is called Glamorous Toolkit. That's also free and open source. It's an extensive environment, and that shows how moldable development actually works in practice, how you can actually have thousands of tools with which you can evolve and understand your system.
So that's Glamorous Toolkit.
Yeah, gtoolkit.com.
Right. I'll put a link to that under the show notes as well. So the book that you're writing, where is that?
That one is at moldabledevelopment.com.
Okay.
It is linked there together with other resources that we make available on the subject. Our company is Feenk, Feenk. The way we get funding, so our company, we created the company as to have a vehicle to fund this research that we basically make free and open source. And the way we get funding is we go and solve hard problems. So essentially, the way we validate the whole theory is the fact that we exist.
You do it in the real world. So you're solving real world problems. You've got real world case studies, and that's the validation that is,
yes,
that is required, which is great. So that book is a kind of work in progress. So people can go there, they can read what's there now, and if they come back in a couple of months, there'll be another chapter or two. Time permitting, yeah, obviously, it's always the case, isn't it?
The process of writing the book is not just, we're not just writing the book and it's just translated what exists, but we're creating explanations. We think this is a very large space. We have the beginning of this conversation, but we want to offer that conversation not only for technical people, but also broaden up in maybe less technical terms, and that requires time to find and
a layer of translation as well, because technical people have an argot, have a very specific set of language that they use that doesn't necessarily always translate to what's being talked about in senior positions and C-suite.
Precisely. And this is why, so especially Simon is particularly adept at this kind of translation. And we're using, in this case, we used extensively word mapping as a way to explain and also to redescribe this, the space, and building the explanation from a completely different angle, so that we can find different kinds of narratives that were not so obvious at first.
Fantastic. Tudor, if people want to know more about you and the work you're doing, is it to go to Feenk or somewhere else?
That's that's all of my work is available, and my colleagues' work is available at feenk.com, Feenk. Feenk comes from feel and think, because we believe that people should not just think in our space, but also feel. So, if we ask developers, do you love working with legacy systems? They will absolutely not associate those two things. And we believe that they should, because legacy should mean value, and it should actually feel enjoyable, and it's possible to make it feel enjoyable.
Oh, well, that's good. Because I think that's right. Look, developers often struggle just with other people's code, right? They'll often rewrite it rather than try and understand it. They'll go from scratch, which in itself is a bit of a time sink in many ways, and can create another set of problems. So I'm going to put a link. I'll put a link to Feenk so that people can see the work that you're doing, and also the Glamorous Toolkit. It's been really fun speaking to you. Thank you so much.
Thank you.
And I look forward to actually following this journey and seeing where it lands up, because it's so relatable to so many of the systems that I've seen in over the years. So looking forward to it.
Thank you.